Okay, we're going. Kinetic energy. So what's kinetic energy in one word? Movement. Thank you, Daniel. This guy's moving on his rocket bike. So kinetic energy is the energy of moving. And this is the formula. Point to it on the wall. It's right up there. So there's kinetic comes first and then potential. This is kind of a simple formula. Half mv squared. And the m is the mass of the object. And the v is the velocity. And this all goes together with our work formula, which is force times distance. Tell me one way that we can create kinetic energy. Yeah, like this? I guess. Farham says, throw it to me. Okay, that's kinetic energy. How do we make that thing move? Good. You apply a force and you create motion. Okay. So think about that motion. Just throw something, like just pretend to throw something. What are you actually doing when you throw something?
Moving?
Yeah, is there an acceleration?
Yeah.
No.
Where do you start from? Like if you just think of the throwing motion.
0 to something.
Good. So I start with 0 and I give it some velocity, right?
You let go.
And then I let go. So that must be an acceleration, right? So what am I applying?
Gravity?
Force.
A force for sure, yeah. Maybe not gravity, but
Potential energy.
yeah, so I'm using the potential energy from the waffle I ate during the potential energy thing. And now I'm using that chemical energy to apply a force and create motion. And so we say that anything that's moving has kinetic energy. Okay, spacecraft Voyager flying through space, but nothing's pushing it. So how can it be moving?
Is it like the air force?
No air out there in space, but good guess.
Because there was force.
Gemma, say that again?
There's no resistance.
There's no friction, right? So it's just moving. Do you have to put energy in to keep something moving?
Not
The answer is no. You actually have to put energy in to stop something from moving. Right? So this can change, but once you have it, if it stays the same, you don't need any energy to be input, and no energy comes out. So for something with no friction, like that never happens here on Earth, but out in space, there's no friction, and stuff can just move. So the moon goes around us with very little friction, and it just keeps going. Jude, you had a question?
Isn't velocity squared acceleration? So
It
can we
has
just
to
not-
do with it, yeah.
So if it was just like, this is your acceleration, could we just use the acceleration without squaring it because it's already velocity squared?
No. Acceleration is velocity over time, not velocity squared. But there is a relationship there. We'll work it out later.
So and when it says v equals speed, what does that mean? Is v equals velocity?
Yeah.
What kind of speed?
Speed is just how fast you're going. Right. So remember that energy is a scalar. It has no direction. So the velocity, it doesn't really matter which direction you're going. You can think of it as speed because the energy has no direction. So it doesn't matter which way you're going. So try this. Solve that.
That's a light.
60 kilos? That's like reasonable.
Yeah.
It's like 120 plus 12.
What was the
It's like
formula?
132 pounds.
What was the formula?
Oh, good question. It's right up there.
975.
So if you just plug and chug, you put the 60 in here and the V for the 5.7. Make sure you find your square button on your calculator. So it would be 30 times about 28 or something, so 600 something.
900.
900? Oh, way off. 974 I got.
Could you just round it up to 975? Because I got that.
Yeah, that'd be fine. I'm not worried about the sig figs. In this one there is 3. Oh yeah, you should be 975 actually.
Yeah.
Good correction. How many people got that? Good. So that's just plug and chug, right? Okay, try this one. I'm gonna say 1.05 times 10 to the 6. Is that right? Did I do that right? Yeah, I think so.
How is it?
What are you thinking, Jude?
I don't know if that's right.
This times itself, if it's 10 to the 3 times itself is 10
Oh
to
wait,
the 6.
plus when
right?
you move it over to the other side, it's 2.1 times 2.
Mhm.
Times 2, 4.2.
No, no, it's 2.1 divided by 2. Which is 1.05.
But do you have to like go like times 2 on the bottom?
No timesing 2. This is the
Well, you
same
have to
as...
you have to times divide 2 over 2.
Because it's saying
No, why did you do that?
And if it's looking for the velocity
This is the math.
square.
Oh my gosh, I'm doing this totally wrong. No wonder you're not nodding your heads. This is the energy. I was thinking this was the velocity, but it's not. Thanks for telling me that. Okay, so this is the energy, not the velocity. I need more coffee apparently. So we have to solve for V now, right? So how are you going to solve this equation for V?
V squared. Yeah.
How do we get rid of the half?
Times by 2 on the bottom.
Good, times by 2. No, not on the bottom. Times by 2 on the top. What's 2 times a half? 1. So then it cancels, it's gone, right? So we have to put that over here. So it's 2ek. And then you have mv squared. And we want to get down to the v.
Divide by m.
So then we divide by m. Good, Marika. Divide by m. And then we have 2ek over m is equal to v squared. And we have one more thing to get rid of. What is it? We gotta get rid of the square. How am I gonna get rid of the square?
Square.
Good. So if I square root both sides, then that's my ugly arrow for today. You're gonna have the square root of 2 times the kinetic energy over the mass should give you your velocity. So just a little bit of algebra. And if you plug that in your calculatrice, so that's going to be 2 times 10 to the
I got 30.
3.
Yes, 31. Yeah, 31.
31?
30.8.
So
I believe you.
What's the number wrong?
meters
That's
per
what-
second.
Yeah, so 2 times 10 to the 3 divided by 2.1 is like, yeah.
The answer's always going to be a meter per second.
31 you got? You sure about that?
When you put this square under this square root, instead of putting this
Yeah.
31.
Yeah.
Yeah.
Okay.
I did better. Is that number?
Okay, I got a 2. 30.9 or so. Bless you.
Oh, that is the same.
That's the E, right? And this would be in meters per second. I don't round it because this is 3 sig figs. Oh, that's 2 sig figs. Yeah, it could be 31. How many people got that one? Okay, you understand how to move the things around and solve? You should really be able to look at the MGH or the half MV squared and solve it for any of the letters in there. And then if you can do that, you can do most any problem. Okay? That is it for kinetic energy. So I have one more little bit of work, but we're done for today.